So here we have a nice algebra problem where we are given that a cubic equation has a real root can be written in a form of this. So we have to find the value of a plus b plus c. So first of all, we have to solve this equation. So we can simply write it as 8x cubed minus 3x squared minus 3x minus 1 equals 0. So to find the value of x, we can rewrite it as 9x cubed minus x cubed minus 3x squared minus 3x minus 1 equals to 0. And if we club this, so here we can say 9x cubed minus, this is our x plus 1 whole cube equals 0, and rewrite it as 9x cubed equals x plus 1 whole cubed. By taking the cube root of the both side, we can say cube root of 9 multiplied by x equals x plus 1. And after taking this x to the left hand side, we can say cube root of 9x minus x equals 1. Now we can evaluate the value of x, which is 1 upon cube root of 9 minus 1. And we know that this is in a form of cube root of a plus cube root of b plus 1 divided by c. So for this, we have to use another algebraic formula, which is a cube minus b cube equals a minus b multiplied by a square plus b square plus ab. So let our a is cube root of 9 and b is equal to 1. So we can simply say that cube root of 9 whole power 3 minus 1 equals cube root of 9 minus 1 multiplied by cube root of 9 whole square plus 1 plus cube root of 9 multiplied by 1. So here we can get this is our equal to 8 equals to cube root of 9 minus 1 cube root of 81 plus cube root of 9 plus 1. So from here we can get the value of cube root of 9 minus 1, which is equal to 8 divided by cube root of 81 plus cube root of 9 plus 1. But our x is 1 upon cube root of 9 minus 1, so we can simply take the reciprocal of the both sides. So we'll get that our x equals cube root of 81 plus cube root of 9 plus 1 divided by 8. And if we compare with our original form, so we can simply say our a is 81, b is 9 and c is 8. So we can simply get the value of a plus b plus c, which is 81 plus 9 plus 8 equals 98. So here we have a nice inequality problem. We are given in a problem that a1, a2 up to an is a positive sequence, and we have to prove this inequality. So for solving this problem, I'm going to start with the AMGM inequality. AMGM inequality. So I'm going to apply this in the first two elements of the sequence a1 and a2. So we can simply say that a1 plus a2 upon 2 is greater than or equal square root of a1 a2. Similarly, we can use the AMGM in a1 and a3. So we can say a1 plus a3 upon 2 is greater than or equal square root of a1 a3. So it will continue up to a1 plus an divided by 2 greater than or equal to square root of a1 multiplied by an. And now we can similarly use this inequality over a2, a3 divided by 2 greater than or equal square root of a2, a3, and it will continue with a3, a4 and all the elements of a sequence, and it will ended up here at an minus 1 plus an upon 2 greater than or equal square root of an minus 1 an. Now we have to add up all these inequalities and we'll obtain the result. In right hand side of the inequality we can simply add the all square root terms, so we can rewrite it as square root of a1 a2 plus square root of a1 a3, and it will goes up to square root of an minus 1 multiplied by an, which is smaller than or equal. So here in the left hand side, if you see that a1 comes exactly n minus 1 many times. Here is our first a2, and from this inequality this will end up here a2 plus an divided by 2, so we can simply say this is n minus 2 terms. So n minus 2 plus this 1, so we can simply say that all the elements a1 a2 up to an, all elements are appearing exactly n minus 1 many times. So we can say that we are adding up a1 plus a2 plus a3 up to an divided by 2, because here we have a 2 in the denominators, so multiplied by n minus 1. So here we have proved the inequality expression by using AMGM.